test. All right, so here we go. First thing you notice is that we are solving some systems of equations, and we are told exactly how we're to do it. Okay, so the first one says use substitution. So when I grade this problem, I obviously I will be looking at the answer, but I'll also be looking at how you got that answer. If we are to use substitution, what does that mean? We gotta get a letter by itself, right? So, might be best just to get this x by itself. You can get whatever you want, but I think it's easiest to say x equals 7 minus 2y. Okay, we're gonna subtract 2y from both sides. Now, this is going to get substituted into here. So 2 times 7 minus 2y minus y equals 4. This gets put right here. So then we can distribute. Collect like terms. And then solve like regular. So negative 5y equals negative 10, and it looks like y equals 2. Now, I graded somebody's homework, I can't remember if this class or not, and on this assignment where you had to do this stuff, this is all that was in the answer blank. Well, that's not the answer. That's part of the answer, right? But what else do we have to do? We gotta plug it back in. The answer to all three of these questions on this first page, the answers are going to be ordered pairs. So we know y is 2. So now we're gonna plug it back in anywhere we want. I'm gonna plug it right here, because if I put in 2, then it just says x equals 7 minus 4, or 3. But you can plug it in here or here. It doesn't matter where you plug it in. Plug the 2 back in somewhere and figure out what your x is. Okay? All right. Next one is exactly the same kind of problem, except we are doing it with elimination. All right, so what kind of work do I need to see for that, Gia? So you want to multiply the bottom equation by 3. So we have 2x plus 3y equals 4. That's our top equation. Didn't do anything to that one. Then 9x minus 3y equals negative 15. You guys, when you decide you're going to multiply by 3, and I think that was a really good choice, everything gets times by 3. Not just the y, everything. So now I can add 11x equals negative 11. So it looks like x equals negative 1. And then what do we do? Just like before, what do? Plug it back in. So x is negative 1. I'll just plug it in the top one there. So that's negative 2 plus 3y equals 4. So I'll add 2. So 3y equals 6, and it looks like y equals 2. Okay? Those problems are on first year algebra tests, right? We've done this forever. The next one is brand new to us. We're going to solve using Kramer's rule. Now, when I grade the substitution, I'm going to be looking for a variable by itself. When I grade the elimination, I'm going to be looking for something like this. What am I looking for when I grade a Kramer's rule problem? I'm looking for determinants. That's right, I'm looking for determinants, 3 of them. The denominator determinant is just the coefficients in order. So 2, -4, 3, 2. That's gonna go in the denominator. I'm gonna get an answer like this. And they're gonna be fractions. And their denominator is gonna be whatever this equals. All right, so how do we do this? Always start here. So multiply those two together and get 4. Multiply those two together and get -12. And then what do you do with those two numbers? Subtract. So 4 minus -12 is actually 16. And that means that whatever x and y are, they're fractions over 16. So what's missing? Well, obviously the numerators are missing. So that's going to be 2 more determinants. So to get my x numerator, I take these two numbers right here and put them, paste them on top of the x column. So 1, -2, and then the -4, 2 part stays the same. So again, as I'm checking homework, I see some of you mixing things around. Don't. Take these and put them right here. So you have 1, -2, -4, 2. Now, when you do y, you're going to do exactly the same thing, only you're going to paste these here. And again, nothing changes. You're going to have 2, 3, and then 1, -2. Now, we evaluate those determinants. So, we start here, so that's 2, that's 8, and I'm subtracting, so that numerator is -6. -4, 3, I'm subtracting, so that numerator is -7. And then to get 100% full credit, there's one more thing you have to do. What do we have to do? Reduce. If it cleans up, you need to clean it up. So the actual answer will be, let's see, we take, 2 out of each of those? -3/8 and -7/16 is our final answer. All right, so a page of your test is going to be a substitution, elimination, and a Precal tool. Another page of your test is just going to be a bunch of matrix operations. Now you might recall that sometimes things aren't possible. So we might get some no solutions. But we won't for problem A. Problem A is doable. Josh or Jacob? Hurry up, leave your phone here. Well, how do we do this? Multiply everything by 2. This is so simple. We're going to multiply everything by 2. So 2, 4, 6, -2, 2, 0, 0, 6, 3. Did I do that right? Or 2. I don't know how I got over 2. Is that better? 2, 4, 6, 2. All right, is that okay? All right, B minus C. Can I subtract matrix B minus matrix C? Is that a doable problem? Yes. Why? They're both the same size. Now, guys, they do not have to be square. They just have to be the same size. And then we just subtract entry by entry. So 1 minus -1 -1 minus 1, 2 minus 0, and 3 minus 2. How's that look to everybody? Okay? All right, next one says A plus B. Can't do it. Impossible, no solution. Why not? How's come I can't add A and B?
Because they're not the same.
They're not the same size. They don't have the same dimensions. Not ever. D times A. Now before I write all that out, I want to see if I can do it. What are the dimensions of D?
3 times 3.
Oh, D has how many rows?
2 by 3.
It's a 2 by 3. Dimensions are rows by columns. Roman Catholic, RC. Rows go this way. They're like bleachers. They go this way. You have 2 of them. Columns go this way. You have 3 of them. So D is 2 by 3. What's A? 3 by 3. Can these be multiplied?
Yeah.
Yes, they can. So I'm going to have to write it all out. So here I go. So negative 2, 1, 4, 0, 1, negative 1. Now, I figured out that I could multiply them by making sure that these 2 dimensions matched. These 2 dimensions tell me how big the answer is. So the answer to this problem is going to have 2 rows and 3 columns. So I'm going to fill in all these boxes. Okay? To do that, this spot right here is the first row and the first column. So I am going to multiply the numbers in the first row, which are negative 2, 1, 4, times the numbers in the first column, which are 1, negative 1, 0. So negative 2 and negative 1 and 0 adds up to negative 3. So that first number is negative 3. Now I do the same thing. I start right here. I use negative 2, 1, and 4. But this time I'm going to multiply it times 2, 1, 3. What do I get? Negative 4 and 1 and 12. What is that, 9? Is that 9? Please, don't be just writing down what I'm saying. First of all, I make mistakes too. And second of all, you need to know how to do this. One more time. First row times last column. What does that equal? Negative 2. Yep. Now, once I'm done with that first row, I'm going to move on to the second row. So now I'm using 0, 1, negative 1. This row of numbers right here. And I'm going to use that row of numbers 3 times. I'm going to use it with column 1, and then column 2, and then column 3, right? So 0, 1, negative 1 is going to be used 3 times. First, with 1, negative 1, 0. Then with 2, 1, 3, and then with 3, 0. All right. I got negative 1 for the first one, negative 2 for the second one, and negative 1 for the third one. Does that look okay? You guys that are moving along here? What does E mean? What am I doing in problem E? I'm finding the inverse. And you remember how to do that?
You take the column and put it
So, first of all, I find the determinant, okay? So the determinant, remember we multiply here, so the determinant will be 3, negative 2, they're subtracted, so I got 5. Then I build a new matrix. And how do I build that new matrix?
flip them
I
and change
flip
signs.
these, so put 3 and 1. And then that becomes a negative and that becomes a positive. And then I put it all together. And how do I put it all together? All these get divided by 5, that number right there. So it looks like the inverse is 3/5, 1/5, negative 2/5, 1/5. Now, just like our Kramer's rule problem a few minutes ago, if something simplifies, you need to simplify it, okay? None of that did, so that's just the answer. Okay, we've done all this. This is all in your notes. You can all go back and look at it and do it again if you want to. All right, AC, multiply A times C. Before I write it all out, can I do it? What are the dimensions of A? 3 by 3. What are the dimensions of C? Whoops, can I do it?
No.
Nope, empty set. Can't do it. The dimensions don't match up. Impossible. All right, now we've got a bigger determinant to do. Okay, so do you remember how to do this? Take the first 2 columns, so we're just gonna take these right here and copy them over here. So 5, 0, negative 2, and 1, 3, 1. All right, and then again, we always start here, guys. Always start with the first number. Multiply those together, negative 15. Multiply these together, negative 4. And these together, 0. And total it all up. So negative 15, negative 4, and 0 gives me negative 19. And then what? Other way. So this is going to be positive 6. Watch your negatives, guys. That's positive 6, positive 10, and 0. So 16. What do we do with those 2 numbers? Subtract. So negative 19 minus 16 is negative 35. Done. Easy. Then you have a vocab section. Jacob,
How did you get the 16 to negative?
you subtract. These 2 numbers are always
Okay.
subtracted. Okay, so now we have our vocab section. What are the dimensions of A? 2 by 4. 2 rows, 4 columns. 2 by 4. What are we talking about in question B? A sub 2-1. What's A sub 2-1? That's second row, first column. So look at matrix A. What number is in the second row, first column? 5. 5. Second row, first column. In the expression 2A, where A is a matrix, 2 is called a what? Uh-oh. Who remembers what we call a real number in matrix land? It's in your notes. Gotta know it. It's a scalar. Kids, what do we know about practice tests? What do the real tests look like? Yeah. You're gonna have vocabulary on your test. What is a square matrix? How would you define a square matrix?
When both numbers are the same.
And let's be a little more specific than that. What do you mean by both numbers?
Like, the dimensions are the same?
Okay, Geo,
Same dimension, same corresponding entries.
that's equal matrices, that's not square. But square matrices,
There's the same number of rows and columns.
there we go, same number of rows as columns. So yes, Scout, the numbers are the same, but the numbers that are the same are the number of rows and the number of columns. Somebody, I think, said the dimensions are the same. I could live with that. The dimensions are the same. That is 2 by 2, 3 by 3, okay? And then define matrix.
A rectangular array of numbers arranged in rows and columns.
God bless her, she doesn't have it memorized yet, but where did she get that? From her notes. You need to memorize that. That's what a matrix is. That's what a matrix is. And then F, I snuck one in there. Define entry or element. What are entries or elements? What are we talking about when we do that? Entries and elements are
Is it a singular number?
they're the numbers inside the matrix, that's right. So these are the entries right here. These guys right here are the entries. The numbers inside the matrix. Okay? Oh boy, and then what do we have? We have our big word problem. So just as promised, everything is set up for you. So what's the first thing you're gonna do when you look at this problem? The first thing you're gonna do is what? Put all the numbers, you're gonna read it, and you're gonna put all the numbers from the words into the box. So what do we got? We have number, we have a fixed interval. We did one of these yesterday, or whatever day I saw you last. Was that yesterday? Yeah. So, we're ready for that, we can do that. All right, a snack bar cooks and sells hamburgers and hot dogs. Okay, stay in business. We have to sell at least 10 hamburgers, but cannot cook more than 40. That is my fixed interval for hamburgers. Hamburgers, which I'm gonna call X, has to be between 10 and 40. Read that sentence and make sure that makes sense to you. I don't know how many hamburgers I'm cooking, but it has to be between 10 and 40. Do you understand that from the words? That's your fixed interval. When you say you gotta be between two things, that's a fixed interval. Okay? Now, what do I know about hot dogs? At least 30, but not more than 70. So my fixed interval for hot dogs is gonna be between 30 and 70. Kendrick?
So we're not, so for these, we wouldn't use a greater than equal to, or we would use greater than.
Well, we will when we write our constraints, but for fixed intervals, it's always less than. Always less than for fixed intervals. Now, that may be different when I do my other constraints or whatever, but let's see how it kind of turns out here. But yes, these will always be less thans in a fixed interval. Okay, we cannot cook more than 90 sandwiches altogether. Where does that go, the 90? That's the total number, isn't it? Doesn't that go right here, the total number? And the profit on a hamburger is 33 cents and a hot dog is 21 cents. How many of each kind of sandwich should it sell to make the maximum profit? So we're gonna maximize our profit. And what does that profit expression look like? 0.33x plus 0.21y. 31 cents for every hamburger, 33 cents for every hamburger, 21 cents for every hot dog. Now, what are my constraints? Well, I know yesterday was the first one we did with fixed intervals, but I told you yesterday that a fixed interval is always a constraint. So I got two of them right here. All right, now, do I have any others? That top row gives me a constraint. What does that one say?
X plus Y.
X plus Y has to be less than or equal to 90. And then just because X and Y are always positive. There's a lot of points on this page. I'm gonna write everything down, so we get points for everything. All right, everybody keeping up to this point? All good here?
Can you re-explain the reason of why X and Y would be a greater than or equal to at the bottom instead of less than or equal to?
Okay, X stands for the number of hamburgers I make. Less than 0 are negative numbers. Can I make negative hamburgers? Okay. That's why, Brennan, when I graph these, I always just graph quadrant 1. That's where X and Y are both positive. I don't set up a graph like this, because I can't be negative. So always over here. Okay, so let's graph it. All right, fixed interval. Remember how we did that yesterday? I'm gonna count by tens, I think. So I'm gonna put, I'll do this with red. I'm gonna put a hash or a dot at 10, 20, 30, and a dot at 40 on the x-axis, because those are my x's. And then I'm gonna draw a vertical line down through both of those. And then I'm going to shade. And where do I shade? Always in a fixed interval. Where do I shade? Between them, right? Between them. So I'm shading right in here. Right here is where it's shaded, okay? Now, I'm going to do the same thing for Y. Only I'm on the Y-axis now. So 10, 20, 30, 40, 50, 60, 70. And my bars will go, or my lines will go sideways. And where will I be shaded? In between them. So, I mean, my boards are a mess, so I'm not shading anymore, but I'm between the red and between the orange. So do you see a box right here? There's a shaded box right there. So then on top of that, I have to put the other one. And how do I graph this one? One letter at a time, right? So I'm gonna cover up X and Y is 90. And I'll cover up Y and X is 50, 60, 70, 80, 90. Now remember, the only part of the graph that we were really looking at before was this box right here. So now I've drawn this blue line in. It cut through the box, but I have to be below my blue line. So I'm in the box, but below my blue line. So I'm in the box, but below the blue line. Do you see a shape like this? In the box, below the blue line. All right, what happens next? We find our points. And some of them are gonna be so easy. Now, this might be the first one that we're not like on an axis, but you know what this point is. Look here where I'm pointing. If we're on this red line, we know X is 10, and if we're on this orange line, we know Y is 30. That's the point 10, 30. Any point on this red line has an X that's 10. This one's 10, 30. What's this one? 10 what? 70. Now, what about this red line? What do I know about the dots on this red line? X is 40, so these are 40 somethings. Well, this one is 40-30, isn't it? Look at that point, use your common sense, look at your picture. Probably clearer on your picture because you have the grid. So 40-30. And now what about this one? This one's still super simple. We already know X is 40 because we're on that line. But we're also on the blue line. And what do we know about numbers on our blue line? They have to add up to 90. So if X is 40, then Y is going to be 50. And the only one left is this guy. What do we know about any point on this orange line? Any point on that orange line has a 70 for Y. But he's on the blue line, so he adds up to 90. So X must be 20. And that's all. Okay, so now what? Now we get our calculator out, and we take each X and Y, and plug it in to this. So 0.33 times your X plus 0.21 times your Y. And this is your profit. This is what I got, but I'll let you double check those for me. Is that right? Okay, so now we finish the problem. There's some space over here. You'll write a sentence, right? Wherever you got room. Write a sentence, and what's that sentence gonna say? They should make. Which one's the highest? Right here? So they should make 40 hamburgers and 50 hot dogs for a profit of $23.70. That seems like a lot of work for $23, but that's what they should do. Okay? All right, one more to do. Last problem is the calculator problem. So what are our dimensions? First thing we're going to do is go to second matrix edit, and we're going to have to put in our dimensions. And what are our dimensions going to be? Guys, how big is our matrix going to be? It's going to be 4 by 5. We need P, Q, R, S, and the equals number. So it's going to have 4 equations. 1, -2, 3, -5, and -34. I have 2 P's, 1 Q, no R's, -4 S's, and -16. No P's, 1 Q, negative R, negative S, and 1. No P's, 2 Q's, 3 R's, no S's, and negative 5. I don't have time to actually type this in, but I need everybody to make sure you understand those numbers. If the letter is missing, you put a 0 in that spot. If the letter does not have a number in front of it, then it's a 1. 1 P. If it's no P at all, if there's no P in the problem, then it's a 0. Okay? So that's what's gonna go in. We're gonna RREF it, and out is gonna come our answer. If our answer comes out as hideous decimals, then we use math frac to change that into